Geography. Let's try geography.
Which of the following is not a state capital? I know that one is. That one is.
Manchester.
What's
New Hampshire.
What's New Hampshire's actual?
Oh. Hey, Jack!
We only have like 2 kids today for the first part.
That's okay. We're better than them.
What's the name of the decrease in the... Oh.
Maybe, I don't
leukemia?
I don't know. That's a cancer of the blood, so...
Leukopenia. Okay, give up.
How are you, Jack? We can't hear a word you're saying, but that's also too.
Is nobody coming today?
I'm here. You're here. Jack's here.
Or no.
I'm someone. I don't know about you. Do you know the poem? Do you know any poems by Emily Dickinson?
Yes, I had to read them and read about them for 10th grade English.
Did you hate them?
Can you hear me now?
Yes, I can hear you now.
Yes, Verizon.
There's a poem that she wrote that starts off, I'm nobody. Who are you? Are you nobody too? I really like. She's a weirdo, like she a really weird person. And yet,
maybe we're nobody
worth
together.
knowing. Worth knowing totes.
Is our project due tomorrow?
Yeah.
8 o'clock. Contact Alex.
Yeah, probably so.
I don't have his number, and he never.
Email.
He hasn't been to class in ever.
I didn't see him last time.
That's when we got the project. I know.
You need an extension. I might give you one.
Really? Is it really hard?
No, it's really easy.
Oh, okay. I just have to find a dumpster.
Yeah, you do.
That's
that right?
Yeah. I need to contact Alex. He's lucrative.
He's lucrative. That means money, like rich.
Okay,
like making a lot of money.
He's
elusive?
Elusive. And he's rich too. Who knows?
I don't know. I can't speak to that.
He's braggins.
Love that picture that I'm showing there.
Izzy's math.
Love that picture.
Oh my god, that one time when I kept sending you the wrong problem set was the most stressful.
That was the most stressful thing. That's sad.
I was having a mental breakdown about it.
Wow. What have you heard from Jasper and his wisdom teeth? Ah!
Well, no one.
Oh, they will show up.
Yeah, never. They're all gonna try to skip math.
You know, if they dang them.
If they skip math, can we fail them all?
Yes. Because we know they'll be back before.
Yeah, well, they might be back.
Yeah, most staff will be back before.
Is it a Monday or a Thursday? You are all for class on Thursday.
Hello, Sam. There's a lot of Sam in the image.
What's my name?
You can zoom out a little bit.
Oh, now there's a lot of Raheem.
Oh, there you go.
And now there's a lot of Akshay. I don't know. And there's whoa.
Alright, now what?
Woo! Look at that room.
You're wrong.
But he's here.
Oh,
yes, he's wrong.
There's Mr. Well, there you go.
Isn't this weird? Doesn't this?
How are you guys?
Good.
Okay, would you like to hear my German joke that
Doesn't this look like me?
So does anyone speak German here?
9.
Nah.
Okay. Do you really?
A little bit.
Okay.
Nothing.
So let's see if I get this right. Wie weiß die Weib die Hercules? And the answer is Frau Cules.
I got that one.
Thank you, Akshay. I know you loved it.
I understood hair and brow.
That's all you need to understand. I actually told that we have a German exchange student here, and I told it to her, and she was like, I didn't think she liked my German. I was so impressed that I memorized a German joke.
She speaks German.
There you go. I haven't seen her today.
You should teach
We have a weird thing happening at our school. There's this blame-o, like, how many kids would you say? 70% of the kids?
Yeah.
Have gone to see this movie, and Jack is at home, and Jasper had his wisdom teeth out, and so...
So class is canceled.
No.
Yay, bye.
What? How can you feel that way? Bullets. Arrows in my heart. Arrows in my heart.
My mathematics.
Alex Powell! is dialing in. I sound on my computer, but I'll join the class as soon as it does. Great. He's probably at home because they don't have school today. I actually don't know that.
What?
Hey, this is my hero here for today, who we're going to talk about today. What's his name? Do you know? Lagrange. What did you learn about Lagrange in BC Calculus?
What is we
Should have learned something about him.
That's funny.
He's your favorite.
You should know. We learned something in BC Calculus about Lagrange.
Did we?
It was like the thing that everyone's like, I don't get it. Yes, woo! The Lagrange error bound. That's where we've heard about him.
Did Charles know it, and then Charles did, and then we were all like, I don't get it.
No, I don't know.
Oh, it's so weird.
You should look that up. Yeah, they will show up. Yeah, they should show up. So Lagrange is someone. Hi, Coleman. Lagrange is someone you should know about because he, you did talk about him a little last year. Here's the first question. Okay, so let's see. What do the following statements mean? Can anyone, let's say, F has a local maximum at AB. So Isabel, get us started. What does that mean?
It means that the gradient is equal to 0 at that point, and that the determinant and fxx.
She's being way more fancy than I was expecting. What does it mean just to, in normal people words?
Sorry. It just means that there is a point that is higher than all the others.
Yeah. So my school is on a local maximum. And it really literally is. I don't know if you have, of course, read The Great History of Moray, written by a faculty member, Al Kilborn. I know you haven't. But this place where the school is located was the summer White House for a couple of presidents. Because it's at a high point, and before air conditioning, it was cooler, like by, I don't know, 1/10 of a degree. And if you've ever been to Washington, right down the street from us is the National Cathedral, which is built on the highest point in Washington, D.C. So you can really see it from
Is
a
it
huge
really?
distance. Yeah, it is. But those are both local maxima. Why are they local maxima?
Because they're not the highest point of all
Right.
of the whole world.
Yeah. So we actually use this term in math, neighborhood. So it's like the highest point in the neighborhoods. And that's true. I have to walk up a hill to get to school. Okay, so Samya, how's that different from an absolute maximum?
Well, the absolute maximum is the highest point.
So what's the highest point in the United States? Do you know? She's just doing a geography quiz.
Oh, McKinley.
It's
right?
Mount McKinley.
It's not called that. Yeah.
Not called that.
Oahu.
Denali.
Yeah, Denali is what it's now
But in
known
the
as.
lower 48,
In the lower 48, it's
Mount Whitney.
Mount Whitney in Washington State, I think. But so that's like an absolute maximum on this, not on this continent, because I'm sure maybe on the continent. I don't know. I don't know what the mountains in Mexico are like, or the Canadian Rockies, but anyway, so that's an absolute maximum.
Wait,
It's the
what?
one that's bigger than any closed set. So we actually have to say, I have to limit myself to, the North America or whatever. You've heard, on Mars, there's some mountain that's 3 miles tall or something like that. There's this humongous mountain on Mars. So that's maybe in the universe, that's an absolute maximum. Rahim or Akshay was saying there's someplace in Hawaii, too. One of those islands is actually from base to top taller than Mount Everest or anything like that. Okay, what's an local minimum, Sam?
Was the question absolute or local minimum?
Local.
Local. Oh. Wait, is it? I guess it's just lower than everything else around it, but not the lowest.
Right, so it's a depression. It's somewhere that's lower than the stuff in the immediate vicinity. So in the neighborhood, as I say, that's such a weird term, but it really is what mathematicians use. So Jack, what's an absolute minimum? We can't hear you. We still can't hear you. We see you going like this.
Oh, he's typing.
Okay.
He's muted.
But why are you muted, Jack? Unmute.
Unmute.
Jack.
Can you not hear him?
What is Selma?
Oh, it's the movie.
It's a movie.
Oh.
Oh, that's the movie the dude was talking about today.
What is Selma?
Yeah.
That came.
It's some civil rights thing.
Yeah, there was
It's
pretty
some
important civil
civil
rights.
rights. It's
Some pretty important civil rights
civil
moment.
rights. You know, I
Selma,
wonder
Alabama.
culture,
Uh,
like at these other.
An absolute minimum. Let's hear Jack writes. An absolute minimum is where a function has a slope cost. Okay, so it can't be on an open interval, Jack. It has to be on a closed interval. So that's an important distinction. And in fact, if we were being really precise mathematicians, we'll see an example in a second. We would talk about closed sets and open sets. So if you think about, are you including the boundary or are you not? And we use these Lagrange multipliers for these closed sets where we have constraints. Okay, Coleman, what's a saddle point?
A saddle point, sort of like a valley,
Mm-hmm.
in a graph. It would be a point, not necessarily the lowest on the graph, but it would be at the bottom. Everything around it would be increasing.
Okay, is that true? Everything around it is increasing?
Okay.
It is in one direction, right? But what's happening in the other direction?
It's increasing.
It's increasing. So it looks like a saddle, right? At the middle point of a saddle, it's increasing in one direction and decreasing in another direction.
You should go horseback riding.
We should. We absolutely should go horseback riding. So I grew up in Texas. I don't know if you know this, Coleman, but I have never been on a horse. Have you ever been on a horse, Coleman?
Yeah.
Only
I've actually never been on a horse in Texas, but I've been on a horse.
An important distinction.
I actually can imagine you strongly disliking horseback riding.
I just can't imagine doing it. It's like, no. I had an opportunity.
On that thing?
I've only been on an elephant, and that was not a pleasant experience. That's all I have to say.
Yeah.
Actually, it was in Thailand.
I've also been on a camel.
I've been on a camel, which was also really bizarre. It's just like those animals are not nice.
Yeah, they're weird.
Okay. So let's talk about how this method works. Sam, no, Sam's already. Alex Powell, are you there? He was there a minute ago.
Yes, I'm here.
Oh, there you are. Alex, can you tell us how you do this Lagrange multiplier thing? Can you explain the methods? Because we're going to do some problems in a second, and, we need to know.
So you know that the gradient of f is I guess proportionate to the function g, which is a constraint.
So be careful. It's not the function g. It's the
or the constraint g.
Yeah, but it's the gradient of g.
The gradient of g. Right.
And I like that you said proportionate, because what symbol do we use with these Lagrange multipliers most of the time, Alex? Lambda. So what the whole idea of this is that you're saying the gradient of g is proportional to the gradient of f. And the interesting thing about it is, why does this work? I mean, why does this literally make sense? Does anyone want to take a stab at that? I will let you try to explain that. Anyone who wants to. Why does it work? Anyone?
Can you repeat the full question? Sorry.
So why does this literally work? Why does the gradient of the constraint tell you where a max or a minimum of the function is? So that's an important question. I mean, it's something for you to... Samia, go for it.
Okay, so the gradient of f and the normal line to the constraint are parallel at the optimum point. So I guess that the gradient of the constraint, it isn't
You're so close. I love what you're saying. I mean, it has to do with level curves too, right? And what we know about level curves. So that's a really, that's a deep question. That question there is, why does it work, is really deep. So what do we know about the gradient of f, Samya? What's true about it?
Well, like the optimum point, how it's parallel to it's parallel to the tangent of the constraint.
Okay. That is true, but I'm trying to figure out why that would be true. Do we need to ponder this some more? Should we do some problems and then come back to this? I mean, because we can do this computationally, but I want you to understand the reason this is true. Do you have an idea? Okay, she doesn't. Anyone want to? Okay, we'll come back to this idea. This is a big idea. Thank you, Samya. You're close, Samya. You're really, really close. Okay, so we'll come back. Let's learn some things about Lagrange. He's one of my heroes. Look at this. He wrote the letter to Euler, one of my other heroes, with the basic idea of Lagrange multipliers when he was 19. What's wrong with you guys? He was 19 when he came up with this theory.
We're 17.
Only 18.
Okay, if you don't have a basic, huge, life-changing, world-changing theorem by 19, you're pathetic.
Yeah.
That's all I can say.
Well, it's just not really fair because math just started simple and got more and more complicated. So now we're working with so much stuff that we would have to go to 8 years of school before we figured anything out.
I don't know what to say. I think you're making excuses for yourself, Isabel. I'm pretty sure. You know, Euler was this guy who was such a brilliant person that he made huge. He's one of the fundamental figures in math. He made huge discoveries in every field of math, and he then took over Euler's job at the Berlin Academy of Sciences. And as I mentioned earlier, he did this Lagrange error bound. Look at this. He proved that any positive integer is the sum of at most 4 squares. Can we try this out? Coleman, give me a number. Any number.
24,189.
Oh, come on. We have to be able to figure out the squares. Give us something a little smaller.
700.
Let's try a number between 1 and 100.
82.
Okay, there we go. Okay, so he said that number is the sum of at most 4 squares. Can we figure out that the squares there?
Yeah.
81 and 1?
Yeah, there we go.
81 and 1.
Now, that's not the sum of 4 squares.
No, or at most.
Zero.
At most 4 squares.
I know, but 81 squared isn't 82.
No.
No, 81 is
9 squared.
I don't like that.
9 squared? What do you mean 9
Oh,
squared?
9 squared. Thank you. Because I thought you were saying 81 squared. I was like, why are you saying that? Yeah, 9 squared plus 1 squared. There you go. Okay, Sam, give us another number. Come on. Okay, so let's try a number between 1 and 1,000.
Oh, no.
350.
350.
Can I use my calculator?
Yeah.
Would it be
Wait, what was the number?
350.
18, 5, and 1?
18, 5, and 1. So 18 squared plus 5, 1. How did you do that?
Impossible.
What's 18 squared, Coleman? I don't know.
324.
324.
324.
How did you do that?
Let's do a power clap for Coleman. 1, 2, 3. Oh, come on. Help me out here. 1, 2, 3. That is impressive. That is really impressive. That's like a party trick.
Coleman.
We had to learn our squares up to 25.
We did too, but
Oh, we only learned them up to
what's 23 squared? I have no idea.
529.
4. Oh yeah.
So you didn't learn them so well.
Apparently not.
I know. So that is a pretty incredible theorem to me, and he proved it. Proved that. That's an even more incredible thing. So then, if n is prime, then n minus 1 factorial plus 1 is divisible by n. Oh my gosh, this guy was a genius. He really was. And I would like to point out that he did not get killed by the French Revolution. Like, what famous scientist was killed by the French Revolution? I hope you know this.
Leibniz.
Lavoisier, who discovered...
Vossner's.
Oh, come on. He discovered oxygen as an element.
Lavoisier.
So Lavoisier was like a victim
Why would
of the
I
French
know
Revolution.
that?
Because you took 2 years of chemistry.
Yeah,
3
but
years
we
of
never
chemistry.
talked about
We
that.
don't
Okay.
do that stuff.
Lavoisier. Who was this guy?
Lavoisier. Okay, let's do 2 problems. Let's do 2 easy problems in this. So let's maximize 2x plus 2xy plus
no.
y, subject to the constraint 2x plus y equals 100.
Oh, there we go.
Okay, so let's do this together so that we can do the harder problems. What do I do first, Raheem?
You find the gradient.
Of which one?
F.
Okay, so Raheem, what's the gradient of f? Really?
What's the gradient of M?
What?
What's the
I
gradient
said, what's the
of M?
gradient of f?
Oh, I'm still doing it.
I'm about to burst into tears, Raheem.
Oh, my bad. I messed up. Okay, so I messed up really badly. So it'd be 2 plus 2y plus y. No, not plus y.
2 plus 2y.
2 plus 2y, that's it.
Okay.
I am about to cry.
2 plus
Say 2
2y.
plus
Raheem,
2y.
you're killing me.
You meant to say 2 plus 2y.
Yeah.
I
And then comma.
plus.
Comma.
Comma 2x plus 1.
Yeah, let me say.
Woo! There you go. That's what I'm talking about. Okay, thank you, Raheem.
Woo.
Akshay, what do I do next? So I have to find the gradient of what? There's only one other function.
Oh, the constraint.
The constraint. Okay, so we have to find the gradient of the constraint. So, Akshay, you're on. What's the gradient of the constraint?
One. No, wait.
Oh my gosh, guys.
It's 2 comma 1.
It is 2 comma 1. Wow, that was rough.
That was really bad.
That was really rough.
That's really bad.
Okay. Okay. Now, Alex Powell, what do we do next? And I'll help you if you want some help.
Next, we set them equal to each other with, or no, we multiply g by lambda, or like the constraint function by lambda,
Yeah,
or the constraint
good.
gradient.
Right. So I have an equation that's, gradient of f equals lambda gradient of g. And so then I practically get a what they call system of equations. One of them is what, Alex? Can you give me one of them?
One of them would be.
So I'm going to set the x ones, the I values of the vectors equal to each other. So
2 plus 2y equals 2 lambda.
yes. Okay, we're good. Okay, Alex, what's the other one?
The other one would be 2x plus 1 equals lambda.
Fantastic. Okay, Jack, now I need to solve for either x, y, or lambda. What do you want to do, Jack? Jack?
He's talking and it's muted.
Uh,
Jack.
So I have
hit
two-
the unmute button.
So I have two equations, and I want to figure out how to get a, so, Isabel, you have an idea.
Well, I mean, we've already solved for lambda, essentially, with
Okay.
one of our equations, so.
So,
there you
well, we could solve for lambda, and then what would you do?
go. Well, now is it wrong to plug it in?
Well, you still would have two equations with two
With
unknowns in one
three.
equation. Yeah. You have an idea? Someone?
No.
Oh, come on. Try something.
Multiply.
Wait.
Can we?
Yeah.
Yeah.
Yeah, go ahead.
Okay, can you just?
Go ahead. I'm listening.
Why can't?
I'm confused. We only have two variables.
No, can you
Well,
just,
we actually have we have another. Hey, we have another equation that it has to be true to, which is, so what's the other equation? It has to be,
Wait.
what's our constraint equation?
2x plus y equals 100.
Right, so I think that's a third equation that this all has to be subject to, right?
Yeah, so you can multiply the second one, so it's like 2 plus 4x equals 2 lambda. So then 2 plus 4x equals 2 plus 2y, and 4x equals 2y, so 2x equals y, and then from there.
Okay, I hear a lot of things there. You know what I'm going to do? I'm going to write my third equation in terms of lambda. Okay?
In terms of lambda.
In terms of
The
lambda.
2x plus y equals.
Yeah, the
okay,
2x
so
plus y
plug
equals
in.
100 in terms of lambda. I have a theory that this will work. So can someone help me solve the first equation? Coleman, can you solve the first equation for lambda?
I got y equals 0. Okay.
Y plus 1 equals lambda.
Y plus 1 equals lambda. I love that. Now let's solve that for y in terms of lambda.
X equals 50.
Coleman.
Y equals lambda. Y equals lambda minus 1.
Fantastic. Okay? Okay, Samya, can you help me do the second equation? 2x plus 1 equals lambda. I want to solve it for x in terms of lambda.
2x plus 1 equals lambda, and solve that for. Put that in terms
X.
of what?
X.
Oh, 2x equals x equals lambda minus 1 all over 2.
Okay, fantastic. Okay, Isabel, do you want to try to solve for lambda?
Okay, wait. So 2x plus lambda minus 1 equals 100.
So I'm going to 2x plus y equals 100.
Yeah, and then
So I want to
plugged in.
substitute in for x a function of lambda and for y a function of lambda.
Okay, so we got that 2x equals lambda minus 1, so x equals lambda minus 1 over 2
Mm-hmm.
minus 1 all over 2. So then your final equation is lambda minus 1 plus lambda minus 1 equals 100. So you have 2 lambda minus 2 equals 100.
I like what you're doing.
And then, keep going. Then you have 2 lambda equals 102. Then you have lambda equals 51.
That is awesome. That's what I got earlier. I got lambda equals 51. Okay, Raheem, I got lambda equals 51. Can I solve for x and y now?
Yeah.
Okay, so what is x?
X will be 25.
Excellent. And what would y be?
Excellent.
50.
50. Now, I actually want to maximize this, so I want to get a value. So I know that the maximum occurs at 2550. So what would I do as my final step, Raheem?
You just plug it back in.
Yeah, I'd plug it back in. I'd plug it into my function. Which function would I plug it into?
The first one.
Yeah, excellent. So can you compute that number?
Yeah. So it would be 2,600.
Woo! Good job.
So would you say...
Okay, now, so let's review what we just did there, okay? So first, this is very algorithmic, so we can learn this quickly. So Isabel, what do? Tell me the algorithm.
So first take the gradient of both the function and the constraint.
Uh-huh. Yep, go ahead.
Okay, then once you do that, so write those equations out. Then set x components like equal and the y, but multiply the constraint by lambda, and then set the y components equal but multiply the constraint by lambda, and then use the constraint as your third equation, solve for lambda, or solve for x and y in terms of lambda, plug it into the constraint, solve for lambda.
And then you can go back and plug in. And your final step is to always find the value. Now, the theory that's incredible here is that it's actually promising that you found either a maximum or a minimum. Okay, and that's the incredible thing about this. So it's actually just a lot of little computations, but you can only use this when there's a constraint, and that's because we need this constraint equation. Okay, so here's a little harder one. It's a 3-dimensional one, but everyone should try this, and raise your hand when you're done with this problem. Also, everyone in Array is sick, except for me. I feel fantastic.
I like method.
I know, it's really a method, yeah.
Like follow.
Yeah. Yeah. Well, that's what's elegant about this. And actually, this would be a good thing to use.
They should totally be back by now.
I concur.
Like, are they just, they said, I thought they were coming back by noon around.
I don't know. I'm not going to worry about it. We're having way more fun than we usually have with those
with
dodos here.
Nice and quiet.
Yeah.
Oh, let's see.
Number 9. 16 thirds. You didn't do it?
Yeah, first.
No, I think it's 16 thirds.
No, did you guys get 1/3?
I got 1/3.
Yay!
Woo! Oh.
Yeah. Yeah, 2x equals lambda, 2y equals lambda, and 2z equals lambda, right?
Yeah.
Okay, so instead of doing what you did, you can just say x equals y equals z.
Yeah, but then it doesn't explain why it's instant.
Oh, wow. We missed it.
Okay, let's see. 4 of us are done. 4 of us are not.
Are we supposed to raise our
Wait, there's
hands?
still.
Yeah, okay, good. I'm liking. Yes, even better. Coleman.
Coleman. Where is Coleman? Fort Worth?
Hmm?
Never been to Fort Worth.
I have.
I've only been to Texas once.
That's so terrible. Okay, Coleman, get us started.
So you want to take the gradient of the equation, and so you get 2x, 2y, 2z.
Yeah, that's true. 2x, 2y, 2z. Excellent. Okay, thank you. Then what do you... Actually, go ahead, Coleman. What do you do next?
And then you take the gradient of the constraint, and you just get 1, 1, 1.
Yeah, so it's nice. Okay, great. Thank you, Coleman. Okay, Akshay, what next?
Alright, so after you take the gradient of constraint, you have 2x is equal to lambda, 2y is equal to lambda, 2z is equal to lambda. So then you solve for x, y, and z, and you get lambda over 2 for all of them.
Yep. Good. So that's fantastic. Go ahead.
Then you want to, well, me and Raheem didn't set them all equal to each other. So, we plugged in and we got 3 lambda over 2 is equal to 1.
Yep.
So lambda is 2/3. And
okay,
then,
so you got lambda equals 2/3. Stop there. Let's see. Alex Powell, what do you do next?
And then after I found lambda equals 2/3, I just plugged that into the equation for x, y, and z in terms of lambda.
And you got what are x and y and z? They're all equal to
1/3.
Yep. And then last but not least, Isabel, what do you do?
Oh, and then you plug it all back into f, and you get that f equals 1/3.
Okay, so you plug it back in. I got 3/9.
I simplified.
Oh, I see. It's the same number. Well, there you go. Okay, so good. Isn't that nice? It's a very nice arrangement.
I feel like you play tricks on it.
What's happening here? This is what's literally happening.
Oh.
Look at how pretty that is. So, did someone explain how this is related? So what is the surface? What is the surface in this world? Yeah, Isabel?
It's a paraboloid.
Well, that's true, but what is it in the terms of Lagrange multipliers? Is it f? Is it g? Is it what?
I would say that the big surface is f.
Yeah, the pretty multicolored thing is f. Okay. What is the circle down below?
constraint.
Yeah,
That's the constraint. And so, I don't know, Akshay, can you, I'm going to make you a presenter for a second. Can you point at where the maximum would be on the surface? No? So where this red line is on the surface, okay? Where this red line?
Yeah, what is the, okay.
So, yeah.
It looks like
that's
the circle
right.
projected.
It's the circle. It's like the circle up on that surface. But why isn't it just a circle on the surface? Well, because the surface is changing, and so that's how this method actually really works. So this is a very beautiful picture of the method, I think. So F is your surface. The G is the circle and the XY plane, and the red line on the surface is where you're looking. It's the constraint on the surface. Yeah.
So that's what it means. You have a constraint and you essentially project it onto the surface.
Yeah.
And your point has to be within that line.
Mm-hmm.
Okay.
It could be on that line.
Yeah.
Okay. It's usually on that line, right?
Right.
I mean, it's always, like in this example, it's definitely on the line.
The max.
Right. And so, Akshay, where would the minimum be?
Probably.
Yeah, down there somewhere.
That makes sense.
So it's the minimum of that surface subject to that constraint. Okay. So let's see if we can do a more complex problem. I don't think this is much more complex, but let's all try this problem again. And I don't think this is much more complex, but it has a little more algebra, I think. So let's see if we can do this. Thank you, Akshay, for drawing that.
How do you find the maximum, or know that it's...
Yeah, good question. How do we know if it's the max or the minimum?
Do you have to do the determinant test?
That's what's so elegant about this. You're just going to find values, and the biggest one is the max, so the smallest one is the minimum.
Oh, sometimes you'll get multiple.
Yeah. Lambdas. So I got 2 lambdas, right? You should get multiple lambdas, maybe.
Oh no, wait.
Yeah. good to go.
How are you done already?
Coleman, you have a question, or you're done?
Oh, I
No, my hand was still raised from last time.
Okay. So
Can
sorry.
you divide by x?
Well, I don't know. What do you think?
I don't think you should, but then you would immediately get answers for lambda.
Well, you can't do that if x could be 0. Could x be 0? I guess it could.
So for this though, like I get to this point, can you just divide and be like lambda
I don't know.
equals 2 and lambda equals 1?
I don't know. What do you think?
Yeah.
Okay. See what happens.
That's how you got it so fast.
I'm wondering.
Is that what you did?
I'm wondering if that's right. We'll see what
It's x
people...
or y equals 0. It's pretty straightforward. So like the maximum is going to be with y is 0.
Let's see, they're talking about something else. Other
No, they're not. They're
values.
talking about this.
He said when y is 0. So obviously you did something different.
Okay, so either x or y has to be 0, right?
So y
Because
equals
you
0
can
could be a
divide.
solution.
Yes.
That doesn't have to
And
be
x equals
because-
0 could also be a solution. Yeah.
Lambda equals 2. Oh no. Oh, where's the constraint? Which one? Oh, x squared plus y squared equals 9. So why does it matter what lambda? I'm having trouble.
Yeah, lambda may not... I don't know. Size.
I thought that
Yeah.
lambda has to be equal to 0.
No.
Well, lambda, I don't think that lambda has to be equal to 0. Why do you think that?
I don't know, because I got
Okay, so
Go ahead, Samya.
I got 4x equals 2x times lambda.
So did I.
Me too.
Oh, so x is equal to 0.
X equals 0 is a solution to that equation.
Wait, so
Okay,
when
so
you
x
look at that,
equals
you
0.
say,
So let's see. I think you have pairs of solutions that are of the form 0 plus or minus 3, right?
what?
Plus or minus 3, 0.
I'm just confused how you interpret these two equations.
Yeah, so we'll talk about it in a second.
Okay.
Lambda equals 0 is not a solution as far as I can tell.
Also, how could that be a solution, really? Lambda.
yeah, x is 0 and y is 0, then lambda. Makes sense.
But x has to be 0.
Yeah, just forget about lambda. Just x and x.
Well,
is
x has to be 0. So y is either 3 or negative 3. So it's 0, 3, 0, negative 3.
That's for
They're back.
Wait, so how does lambda help us in this case?
It may not in this particular example.
Okay.
I mean, it may, but we have to always use this method when we have a constraint.
Okay.
This is the only way we can deal with the fact that we're finding absolute max and absolute mins.
So the constraint really just gives the closed region that we're looking
that's
at.
right. That is true.
And is it just the line or like the curve of the x?
Yeah,
or
I'm
is
going
it,
to
like,
show
the
you what
whole
this looks
area?
like in a second. So you'll see what this looks like. So I've come to a conclusion. Have other people?
yes.
Yeah.
Yes? No? Excuse me.
Yeah.
Okay. I'm going to plug in my, what is this called, computer. Maybe.
Coleman's typing.
I don't count
Why
my
can't they just say that?
You didn't squares?
No.
Okay. What do you think, Sam? What do you think the max and the min are?
Okay, so the maximum is 18. And the minimum is 9.
Okay, explain why.
Okay, so so you get 4x equals 2x lambda and 2y equals 2y lambda. And if you try dividing by 2x or 2y, you get 2 equals lambda and 1 equals lambda. So obviously you can't do that. And the only case when you can't do that is when x or y equals 0. So you know.
Yeah.
So let's go from there.
And so then how did you find out what your y possibilities were, Sam?
Oh, well, because if x equals 0, then, yeah, I guess you go back to the constraint. So you would do like 0 plus y squared equals 9, so y has to be 3 or negative 3.
Okay, and so I had 4 sets, I had 4 ordered pairs, 0 plus 3, 0 minus 3.
Also when y equals 0, and then...
Yeah. And so that ordered pair is plus 3, 0.
0 and negative 3.
Yeah. Okay, cool. And then what'd you do, Sam? You...
Just plug in chug.
Yep. And how did you know that 18 was the biggest?
Because 18 was bigger than 9.
Yes, because 18 is bigger than 9. He's good. That guy is good. Okay, so 18 is bigger than 9, and that means you're just comparing, like, the values that you get, and the largest is the maximum, and the smallest is the minimum. Are you trying to give Sam a high five, and he's refusing you, Raheem?
Yeah.
I know. I hate that when that happens, right? Sam is you're cruel.
If there were anybody
Give the dog a bone. He wants. Oh my God! There you go. Thank you. You just told your. He's not going to do it.
Texas.
He's
and I want to
Here, Raheem.
Who's this?
Here you go. There you go. Okay. Now, let me show you a quick picture. So let me show you this picture so that you can see this. What this looks like. It says my screen is being shared, but it's not. Share.
Yeah.
Maybe it's showing my screen. No. Okay. Here we go. Here's the solution of this. But I want to show you something fantastic, which is this picture. Oh my gosh, why is it spinning? Okay, here's the fantastic picture I wanted to show you. Okay, can you explain what this picture is? What am I looking at here?
Saturn.
No. It's relevant to this problem. So see if you can figure it out now as well. So it's relevant to this problem.
So x squared.
So it says shown in the figure are the level curves of f. So which are the level curves of f? That's all the red stuff and the stuff in between,
Yeah,
right?
Purple to red.
Yeah. And the darker values correspond to smaller values of f. So that as you go inward, it's actually, getting smaller. And then the level curve, it says notice that the level curve f of xy equals 9. Where the heck is that?
F of xy
is tangent to the circle at 0, 3.
Yeah.
And at 0, negative 3. So
that's cool.
Okay, so this is what Samya was trying to get at earlier, right? Why this works. Okay? It has to do with the tangency and the level curves. Okay? So can you explain what you're seeing here, Isabel? Because let me just make sure we got this.
So you look at the level curves of the function and see wherever it's tangent to the constraint. So you see at y equals 3 and y equals negative 3, it's tangent. And then at x equals 3 and x equals negative 3, they're tangent. And then those will be the maxes and the mins.
Okay. And how is the gradient helping us see where those points are?
So the gradient is going to be normal to both the circle and the level plane. So
which is really cool, isn't it?
Right.
I mean, that's a very cool thing. So this image is an important one for us to think about, and we'll consider it again a bit later. Okay? So we did good on the problem. I'm proud of you all, so I'm going to stop sharing now. Okay, and then I'm going to go back to my document, which is this document. Okay, and here we are again. Okay, let's look at a couple more problems. I hope this is a pretty algorithmic thing. You always use it when you have a constraint. Okay, it's the only way. It's exactly equivalent to when you were doing problems in single variable calculus, where you had you could only find relative or global. What are they called? Relative or local minima, extrema on an open interval, but you could find absolute on a closed interval. Okay, here's a question. Can you read this for us, Raheem?
Pictured are a contour map of f and a curve with equation g of xy equals 8. Estimate the maximum and minimum values of f subject to the constraint that g of xy equals 8. Explain your reasoning.
All right, so I don't even know what to be thinking about when I look at this. What the blue represents what, Raheem?
F.
Yeah, it's F. Okay, and what do the numbers in the blue tell you?
That as you go towards the negative y, it gets steeper. Right?
No, less.
It gets smaller, doesn't it?
Yeah, smaller.
But as you get, you're right, Raheem. You are saying something correct. As it's actually steeper in the negative y direction than the positive y direction. How can you tell that?
Because the lines are closer.
Yeah, the lines are closer together. Okay. Now, what's the red thing represent, Coleman?
The graph of G.
Yeah, and that's the constraint. So that's telling you how. So, okay. Now, Alex Powell, you want to try? Where do you think there's a maximum and a minimum?
Well, I think there's a maximum where x equals 0, because that's where the constraint has the highest value.
Okay, and what would that maximum be?
So it looks like it would be just a little bit under 60.
Okay, so you're going to say 59 or something like that?
Yeah, so just it basically looks like it's touching, so I'd say 60.
Okay. Samya, where do you think the minimum is?
30-ish.
Yeah.
Yeah, 30.
And tell me why.
Because the constraint, the level curve of the constraint is tangent to f at that point.
Mm-hmm. Yeah, great. Okay, so that's pretty easy, don't you think?
That is easy. I like this method better than the lambdas. Yeah.
Well, but the lambda, I can see if it's 59 for real or if it's 59 for fake. Okay, let's get started on this problem because this is a much more interesting problem to me. Okay, could you read it for us, Akshay?
Let f of xy equal x to the alpha, y to the 1 minus alpha. Where 0 is less than alpha is less than 1, find the value of alpha such that the maximum value of f on the line 2x plus 3y equals 6 occurs at 1.5, 1.
Okay, I have no idea how to get started on this problem. I have no idea. No idea at all. I'm pathetic. Do you want to help me, Isabel?
Yes.
Okay, so help me get started.
First, take the gradient. Yay.
Okay, so I'm going to take the gradient of f. Okay.
So the gradient...
Wait, hold it. I have to take the gradient of f. It takes me a while.
That's what I was going to say what the gradient is.
Oh, it's not easy, my friend. The gradient of f is not a pretty thing. I did this earlier, and it is not.
Well,
it is an ugly thing. Okay, I disagree, but, that's okay. We don't have to agree on everything. Anyone have a gradient that they like, he or she likes? You have a gradient already.
Yeah.
Okay, let's see if it's right.
Okay, I have a times x to the a minus 1 times y to the 1 minus a.
Okay, true.
Comma.
Except it's alpha.
Sorry. Comma x to the alpha times 1 minus a times y to the negative a.
That's pretty good. You did that pretty fast. That took me an hour to do yesterday.
No, it didn't.
It didn't take me an hour. It's true, it didn't take me an hour. Okay, Samya, what do I do next?
Now we take the gradient of 2x plus 3y equals 6.
Excellent. So that's an easy gradient. That one didn't take me 2 hours.
2, 3.
Fabulous. Okay, Sam, help me out. Next steps.
So I guess you're finding lambda. So you would do alpha x to the alpha minus 1 y to the 1 minus alpha over 2 equals lambda. And then...
Yeah, good luck with that. How are you going to solve that for lambda? Or x? Or
Be fine.
I don't know. Well, the other thing you could do is just multiply the partial for x. You can multiply that by 3 and multiply the partial of y by 2 and then set them equal.
Oh my gosh, that's an interesting idea.
Wait, say it again.
Yeah, I don't know. I mean, I think it's a really interesting idea, but I don't think I'm going to... What am I trying to solve for here? I'm trying to solve for alpha. And what do you know? You know something about where the x and y value at that point, I think. Don't you? Yeah?
Okay, so I would set the components equal with the whole lambda thing and write that out, and then I would plug in 1.5 for x and 1 for y, and then you're just left with alpha and lambda.
Yeah,
variables.
and then you're left with some alpha and lambda variables. So let's do that. So do you see why I can do that? Can someone explain why I can do that? Akshay, do you understand why I can do that? It's because I know what? Help him out. Why can I do that? Or why can Lisabelle do it?
Because they give you a point.
Yeah, I know where the maximum is. Right? I know the x and y value where the maximum are. Maximum is. So I can actually plug that point into my expression. So I got an expression that was alpha times 1.5 to the alpha minus 1 equals 2 lambda. And my second expression was 1 minus alpha times 1.5 to the alpha equals 3 lambda. Now, what can I do? I have to do some horrible algebra. So Coleman has an idea, yeah? Coleman?
Where do you get the 2 lambda and the 3 lambda again?
Oh, yeah, Samya gave me those numbers. Where did I get the 2 lambda and the 3 lambda, Samya?
It's the gradient of the constraint.
Yeah, it's the gradient of the constraint, the 2x plus 3y equals 6.
And the x component becomes what your x...
So I had that ugly expression, right? The gradient of f, the I component was this ugly, horrible expression, and that equals 2 lambda. So do you want me to read that expression for you?
No, I have that.
Okay, and then my ugly j gradient of the f equals 3 lambda. So I now have an expression all in alpha and lambda, but I don't know how to solve it for alpha or lambda. I don't know what to do. Alex Powell, do you have any ideas? Because I'm trying to solve for alpha.
I guess, could you do like a system of equations kind of thing?
Well, but I've got a system, and I've got 2 unknowns, but I'd like to get rid of one of the unknowns.
So if you like kind of did it algebraically and did like you took alpha times 1.5 to the alpha minus 1 equals 2 lambda, and like multiply that entire thing by -3, and then do the same thing for the other equation, just multiply it by 2, and then you kind of like get rid of lambda that way.
You can totally do it. I think it's a really hard way to do it. I mean, you can do it that way. I was going to suggest dividing the two equations. The reason I'm suggesting that is because lambda is not 0. I know lambda is not 0. And if you divide both equations, lambda will go away. So you got an expression?
Oh, I just set them equal.
Why could you set them equal?
Because if you just divide one side by 2, or divide one equation by 2 and one equation by 3.
So you couldn't set alpha, what you originally have, equal to the other thing.
Right, so I just divide both sides by the coefficients, set them equal, and then get like kind of a funny equation, but it's easy to just cross multiply
and you can actually solve for alpha. The answer is alpha equals 1/2. And I think, you got it? Good. Well, so my idea was to divide both equations, and then you have this 1.5 to the alpha, and you can rewrite the alpha and 1.5 to the alpha minus 1, so it works out nicely. Okay. I don't think we should invite the other kids back.
Yeah, that was better without them.
It was way better without them. So,
Are you gonna get mad at them?
She wants me to get mad at them. How can I be mad at them? Because class was so great today, and they were so,
I know,
whatever.
but they got back at like 30, and they just
whatever.
never came. No.
Yeah, I'll be mad at them.
Yeah, if I skip.
Okay, so we will meet again on Monday. We'll talk more about Lagrange multipliers. You have something, if you need an extension, let me know. The thing is supposed to be due tomorrow. It's easy to do, but it is supposed to be due tomorrow, so let me know if you're having trouble connecting with your partner. Yeah, Raheem.
Do you just want us to submit one for
Just one for a pair.
It's just minimizing cost of the dumpster.
Yeah.
It's just like the milk cart.
There you go. It is just like the milk cart problem.
We got this.
Have a fantastic day, and I'll see you on Monday.
I have a test and I want to.
Bye.
Thank you.
Bye.
What did you say?